Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal. My matrix number is 202588. This video is about S71, Static Engineering Mechanics EMM 3103. So we have summary. Throughout the video, uh, we're going to discuss about basic concept in statics, force system, equilibrium, analysis of frictions in bodies and structure under static condition. Statics, the branch of mechanics that deals with bodies at rest or force with equilibrium. Fundamental of quantities. This is the table of fundamental of quantities. Mass, we have kg in SI unit, pound times second square, fits English unit with 1 slug equal to 14.59 kilogram. Idealization. Particle has mass but no shape and dimension. Rigid body composed of a large number of particles that remain at a fixed distance from each other. Point force. Force assumed to act at a point on a body. Newton's three laws of motion. First law, a particle originally at rest or moving in a straight line with a constant velocity tends to remain in this state provided. It means if you apply all the uh, all same forces to every angle of body equally, so the body doesn't is remain at rest. If it's moving in straight line, it's remain at stay in a straight line. Second law is a particle act upon by an unbalanced force experience an acceleration that has the same direction as the force and magnitude that is directly proportional to the force. So F force equal to mass times acceleration. Force is vector, mass is scalar, and acceleration is vector. So the things is if you apply the unbalanced force is from the constant velocity, it can accelerate the motion. So the third law is the mutual force of action and reaction between two particles are equal. It means explosion and like explosion. Uh, or for example, we can apply in our everyday life is like playing football. You kick the ball go the same force as the force you apply to your leg, the force that leg apply to the ball. Force system. Force system, when a mechanic problem of all system has more than one forces acting. Force system have two downline is coplanar and non-coplanar. So we have scalar and vector. What is scalar? Scalar is physical quantity that has magnitude. For example, length, mass, and time. There's no direction in this quantity. Meanwhile, vector, a physical quantity that has both magnitude and direction. So like a force has direction. If go to the right is go positive and go to the left is go to negative. Same as the acceleration. Positive mean accelerate, negative mean decelerate. Coplanar force resultant. To resolve for each force into x and y component at respective component using scalar algebra. Resultant force is found by adding the respective component of each force. So this is the question. What is meant by each force is represented as a Cartesian. Is uh, you can split the F1 into the x-axis and y-axis. So F1 xi plus F1 yj. What is I and j? I is represent x-axis, yj is represent y-axis. So it same goes as F2, F3. And what is Mean by negative and positive, negative is go to the left and positive mean one go to the right, or for the y-axis is positive go to up and negative go to down, go down. Find the resultant by adding respective components. Vector notation, Fr equal to F1 plus F2, F3. So from the equation above you just substitute into the equation. So next, you essentially are just only add this, add or minus the same thing. Plus and minus only apply to during when algebra, plus and minus apply to the same thing. If the algebra is I, only I can add with I or minus with I. Same is G. So we we obtain the FRXI plus FRYG. Next, scalar notation. For that, take note FRX equal to summation of Fx, while FRY equal to summation Fy. So we obtain the Frx equal to 1 F1x minus 2 F2x plus F3x. Fry equal to 1 Fy 1y plus F2y minus F3y. So the magnitude you use Pythagoras theorem. How? Fr equal to square root Frx square plus Fry square. To get the angle equal to tangent negative 1, tangent power of negative 1, Fry equal over Frx, y, because tangent is meant to opposite over adjacent. So from the angle we obtain that Fr this Fry is opposite the angle that we select, and adjacent is Frx. We're going to get that answer. Next, equilibrium of a particle. Condition of a particle to be in equilibrium is no net force acting on it. This means F resultant equal to summation of F equal to 0. So in this, we're going to focus on particle and rigid body. So this example. And to answer this, first you need to draw an FBD of particle O. Next, write the unknown force and note F1, F2, F3 in Cartesian vector form and apply the three equilibrium equation to solve for the three unknown Fx, Fy, and Fz. So this all we get we can extract from the diagram. So this is summation of Fx equal to 0 minus 2x plus Fx. So Fx equal to 200. 400 minus 300 plus Fy equal to 0. Fy equal to negative 100 Newton. Why all these kind of Fx as summation of Fx, Fy, Fz equal to 0 because it's statics. There's no movement or expected to be moved. So that's why summation equal to 0. So Fx, so we obtain the F for this part, the F, because we have F1, F2, F3, and another F. So this. So 200I minus 100J plus 200K Newton. Rigid body equilibrium, free body diagram. So this is, for example, the truck. You need to bring up the plywood, something, the stack of wood. So we sketch a free body diagram. So this is question. A man raised a 10 kg joist of length 4 meter by pulling on a rope. Find the tension in the rope and direction at A. So first, same applies as the particle one. Draw FBD, label, I mentioned F1, F2, F3, and Fx also. This one we already draw the FPD also, and you can apply the cos rule and cosine rule. So in this, to obtain, okay, just go through the Fy, F, AF, EF. This one is 45 degrees. So what is cos? Because it's adjective. When it's my simple understanding is when you near to the angle you touch the angle, you're going to use the cos. And what if you did not touch the angle, you use sine. So in this we got all sine danger, so we obtain alpha. So in this part we use sine rule to determine magnitude of reaction Fr. Because we already have 91.8 weight on this T2 below. So we apply sine rule to obtain T and R. Friction analysis. Friction is the motion resisting the relative motion of solid surface, fluid layers, and material elements sliding against each other. So we have 6 components that we just go through a 7 component. Dry friction, wedges, screw, flat belt, collar bearing, and this channel bearing rolling resistance. Left top we have the dry friction. Right bottom we have wedges. So this kind of look can go to focus on. So same have screw, flat belt, pivot, and collar bearing, channel bearing, and we have a rolling resistance. That's all from me, and thank you.